Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
With the Year of the Snake well underway, I welcome you to Transum Podcast number 123. That's 123. Can you believe that? It's for the month of February 2025, a month with exactly 8 factorial minutes. And we'll begin as usual with the puzzle of the month.
How many different asymmetrical triangles can be drawn by joining 3 of the vertices of a regular hexagon?
That's the Transum puzzle for this month. The challenge is set. Have a think. Make a plan. You have 1 month to figure it out. Send in your solution as soon as you can.
If you get an answer, I'd love to hear how you solve the puzzle or how your students solve the puzzle. Drop me an email to podcast@transum.org. And while you think about that, here are some of the key resources recently added to the Transum website. Subscriber Sharon suggested 3 more panels for the exceedingly popular Refreshing Revision. As you may know, as the teacher, you can choose any number of topics for a projectable starter customised just for your class. So the system randomly chooses quick questions on each of the topics that you've chosen and gives your students something to think about at the beginning of the lesson. I personally use it for most of my lessons as the sort of do now activity, and I choose topics that we've done recently that I want to keep fresh in the minds of the students. So the 3 panels recently added are estimation. That's estimating answers to calculations by rounding each of the individual numbers to one significant figure. Pie charts, that's working out the angle or working out the number of items given the angle of the sector in the pie. And what is the equation? It's a straight line drawn at perhaps a less familiar angle, and you have to figure out what the equation of the line is. So there it is. The links to all the things I talk about in this podcast can be found at transum.org/newsletter. And if you're listening to this far into the future, you'll need to go to the archive back to the February 2025 newsletter to find the links that I'm talking about. Okay, next, tree diagram creator. So I often find myself needing to quickly sketch a probability tree diagram to represent a situation. And it's often difficult to get the spacing right. Do you know what I mean? So particularly if you've got more possibilities, it can get very cramped. So this handy little tool online, which is for subscribers only, does the spacing for you so that you just need to sort of type in the percentages and tweak it as you need. You can delete branches if they have a 0 probability to make the diagram look simpler. So again, the link is in the newsletter. Square Numbers is a new interactive resource focused on developing fluency with square numbers. The 6-level progression guides students from basic 1-digit squares through to more challenging 2-digit calculations, with each level building systematically on previous levels. And level 3 features a exciting timed challenge that helps students to develop their accuracy and speed, I guess, presenting randomly generated numbers between 1 and 12 that they have to square very quickly. Compliments to 100. I'm not sending my good wishes to that square number, but instead it's the name of a straightforward yet engaging activity which offers opportunities for learners to practice identifying pairs of numbers that sum to 100, helping them develop greater confidence and fluency in many aspects of number work. So there is an element of randomness in the generation of many of the questions, which enables two students using separate devices, which will come up with different questions, to work on this exercise together without being tempted to simply copy each other's answers. So I found that works well, and their discussion will focus on methods rather than outcomes. Oh, and this randomness, which is found in many Transom activities, it also makes it worthwhile for learners to revisit an activity on different days to consolidate their understanding, because they'll be presented with different numbers, different questions. Okay, circle parts is moving better than keeping still. And what I mean by that is, would a dynamic visual aid showing lots of different positions of parts of a circle give a better understanding than static images you'll find maybe in a textbook or on a worksheet? So this is a thing that moves around a lot, and you can control it with little tick boxes so that students can learn the meanings of sector, segment, semicircle, tangent, chord, radius, diameter, circumference, etc. So I do hope this resource, it's designed to be projected for a whole class to see while you talk through it. So I hope that does turn out to be useful for you. Now, this coming month, February, a lot of schools will have a half-term break within February. There's not much in the diary that I've got here, apart from the 5th of February has a palindromic date. So if you write it down in a particular way, it can read the same forwards as backwards. And there is a starter design for Valentine's Day on the 14th. So again, links are in the newsletter. Have a look at those. Now, I can't really talk about this very well on the podcast, but if you go to the newsletter, I've posted a picture of what I notice in the afternoon here in Thailand. I can look at my analytics dashboard and see blue circles on a big map of the world, indicating where people are currently engaged in Transom activities. I've no idea who they are or how many there are even, but the size of the blue circles on the map, I guess, are in proportion to the number of people at that particular establishment using Transom. And it's very obvious that there is sort of a big straight line going from New Zealand in the bottom right up to the UK in the top left at a particular time in the afternoon here in Thailand. And the blue blobs, form sort of a straight line. And I think, that looks like a bit of a negative correlation between longitude and latitude. Or am I reading too much into it? Maybe I've been a math teacher for too long. Okay, moving over to Germany, because I have a friend, Alan, who teaches at an international school in Germany. And he says,
I learnt a couple of German shape names. Dreieck means 3 corners, a triangle, and Viereck, meaning 4 corners, a quadrilateral. Why in English do we use triangle more often than trilateral, and quadrilateral more often than quadrangle?
So that's quite interesting. I'd never thought of that before. So I looked up the definitions. First of all, triangle, obviously tri meaning 3 and angulus meaning corner in Latin. And that's the standard word we use for a 3-sided polygon, which is obviously based on their vertices. But the other word, trilateral, is more often used in context referring to political or diplomatic arrangements, for example, a trilateral agreement rather than geometry, but that would be the 3 sides derivative of that word. So the other one, quadrilateral and quadrangle, we do the opposite. We choose quadrilateral, 4 sides from the Latin, and that's the word that we use for a four-sided polygon. And the other word, quadrangle, which is based on the angles, and that's taken on more of an architectural or spatial sense. You know, courtyards or college quads enclosed by four walls or buildings, called a quadrangle. So, yeah, thought that was very interesting. Okay, now the answer to last month's puzzle, which was...
It's the end of the morning break at Adwell School, and 10 classrooms packed with enthusiastic students are waiting for their next lesson to begin. 10 teachers leave the staff room one by one after consuming their morning coffee. The first to leave is Professor Hamni Shah, who can't remember which class he is timetabled to teach, so he chooses a class at random and begins teaching them. The second teacher does the following, goes to their timetabled classroom. If there is no teacher inside, they teach their scheduled class. Otherwise, they choose a random class with no teacher and begin teaching. Every one of the remaining 8 teachers does the same. What is the probability that the last teacher out of the staff room, Ms. Latter-like, teaches their timetabled class?
So the probability that Miss Latte-like teaches her timetable class is 50%. So how did we get at that answer? Well, my first instinct was to simplify the problem and say, well, if instead of 10 teachers, imagine there were only 2. It would then be easy to draw a tree diagram. Haha, you can use my tree diagram creator here. Then it's very obvious that the second teacher teaching class number 2 works out to be 50%. So then I increased the number of teachers involved to 3 and also got an answer of 50%. And then I went to 4 teachers and lo and behold got 50% again. And at this point I started to think there was a pattern here. So you can see the tree diagrams that I drew in the newsletter. And, well, this puzzle was based on the airplane seating puzzle. And if you look that up online, you'll see lots of different ways of thinking about that. This is where passengers get on board a plane and the first passenger has lost their boarding pass, so they sit in a random seat. So one of the solutions I've sort of paraphrased, suppose that whenever a teacher finds their classroom taken, they politely evict the wrong teacher and take their own class as scheduled. In this scenario, the first teacher, which would be Hamni in this case, keeps getting evicted and must choose a new random class each time. Eventually, by the time all the other teachers have left the staff room, Hamni is forced by process of elimination into his scheduled classroom. The scenario is the same as the original process except for the identities of the people in the classrooms. So the probability of the last teacher finding their classroom already occupied is unchanged. So, yeah, does that make sense? Well, obviously different methods of solution will appeal to different people and different ways of thinking. And Rick has sent me a couple of ideas, which, again, are at the bottom of the newsletter page. So have a read of those as well. So anyway, the answer was 50%, and it turned out to be the hardest puzzle of the month yet, due to the lack of correct answers received. But there was an easier supplementary puzzle.
In a room of 100 people, 99% are left-handed. How many left-handed people have to leave the room to bring that percentage down to 98%?
And the answer to that was also 50. But just 50, not 50%. Anyway, the first 5 communications I received about either of the puzzles came from Rick, Robin, Alan, Kevin, and Shrek. Thank you, everyone who took part. It was difficult this month. Hopefully this month's puzzle of the month is a little easier. That's all for now. Oh, apart from to say, are monsters good at mathematics? Not unless you count Dracula. Not unless you count Dracula. Not unless you count Dracula.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transum subscriber.